All right, so at Atomic Jolt, one of the things that we do is we build lots of different applications for clients all over the country, usually in the education space, but not necessarily. So in order to make our development process faster, we've come up with a number of different starter applications. I'll show you a couple of them just really quickly. If you go to our GitHub account, these are all open source. They are MIT licensed, which means you can do anything you'd like with them. We have this Canvas starter app, which allows you to build applications that integrate with the Canvas learning management system. If anybody wants to do that for a hack project, that's an interesting opportunity. We also have just the React starter app. If you want to use Ruby on Rails on the back end, along with React on the front end, all of the hard work is done for you. The stuff I'm going to show you today, I'm going to show you this React client starter app. So this is a new one. The other applications build on top of this. But this takes away all of the pain of the setup that you typically have to endure every time you start a new project. So who's worked with JavaScript previous to tonight? Who has built significant projects in JavaScript previous to tonight? Okay. Who's used Webpack or some other build tool to, so we got one over here? Okay. Getting all of your JavaScript tooling set up can take a very long time. I know because I built this application, it took me a while to get it just the way that I like it. I'm going to walk you through a couple pieces of it. Here we go. So this application comes with a nice README. It's fairly simple. This will let you build your front-end application. This does not have any server backend. It's just a front-end static application. And it'll help you build that fairly quickly. The beauty of this is that you can then deploy it to S3. So you can configure your S3 buckets as a website, and when you do that, you've got this almost infinitely scalable static website that does dynamic things because you use JavaScript to create it. So here's just the instructions. You can actually, if you're interested, go out and pull this down. It's just github.com/atomicjolt. It's the React client starter app. You can do this while we are talking here. The README will run you through all the details, but basically you install a gem, so you'll have to have Ruby installed, which is really not that big of a deal to get it installed. You install the S3 website gem, you go out and you create an account on Amazon Web Services. This is the hardest part, is the step 3, and that's why I've listed out the details right here, but basically you just have to set up a user, get your key and secret, throw that into this project, into, it's probably hard to see from the back. Sorry, Sublime won't let me make this part of it bigger. This is the example file. The actual file has my key and secret in it, so I'm not going to open it. But you can see you just put the ID and the secret and the bucket in there. This will configure that bucket to be a live website, and you have a static website up and running within probably a couple of minutes. So this will save you a lot of time if you quickly want to get an application not only up and running, have all the tooling done, and get it deployed. All right, so we use Webpack. I'll just show you a couple of little pieces of that really quickly. Webpack is a tool that, well, actually, let me show you a little bit of code before I show you Webpack. So this is what React code looks like. And if you'll notice, we do things like import React from React. Now, that will not work in a web browser, right? This is what is called ES5. It's the current version of JavaScript that's commonly available across all the different web browsers that you typically work with. But we prefer to write most of our code using ES6, which is actually publicly available as of June of this year. We even use some ES7, which will not be available until next year. But the reason that you can do that is because we have a tool called Babel. Has anybody ever heard of Babel? So we've got a couple of people that use Babel. So Babel will take your ES6 and ES7 code and transpile it back into ES5 code. So when this actually hits the browser, it does not look like this. But that's okay, because I can write code using a much nicer syntax, but deploy it to browsers that are commonly available across the world today. All right, so part of the magic of this is with Webpack. So one of the plugins that we use with Webpack is, of course, Babel. You can see that right here. It's one of the JS loaders. So Webpack has this notion of loaders. So based on different kinds of file types, Webpack will read that file. It will interpret the code and turn it into something else. So in this case, it's going to turn all of this JavaScript right here into an ES5 syntax. So here's the JS loaders. You can see there's the Babel loader. That's really the only one that we use for JavaScript. Stage 0 means that we've turned on basically every option that there is, so we can use really cool ES7 functionality. And the optional runtime includes some code in your finished bundle. So at the end of all of this compilation process, you'll end up with one JavaScript file that's minified, but it'll include a runtime that does things like polyfill promises. I don't know if you've ever worked with promises in JavaScript. Some browsers support them, some older ones do not. So having that runtime in place, make sure that that works. Okay, so just really quickly, down here you can see here's where we set up the loaders. So we have JS and JSX running with the JS loaders. Webpack will also read your CSS and less files. So if you want to write your code using Sass, if you want to write your styling using Sass or less, you can use those files. And interestingly enough, if you really want to, you can come into your JavaScript files and do things like require styles equals require, and then some CSS, SCSS. SCSS. So you can include your CSS script into your JavaScript if you want. We don't typically do that, but it's available to you. Webpack can also do things with your images if you want. That it will take your images and optimize them for the web, so it can shrink them down. It can change the names of them. Frequently, when you deploy to the web, you will add some kind of a hash to the name of your file. And the reason you'll do that is because as long as that file doesn't change, the hash will stay the same and browsers will cache it. Then as soon as your file changes and you have updated code or a changed image, that hash is going to change, right? Because if you run a hash on a file, it's going to give you a unique value. And then when it changes, the browser knows to go out and get the new version. So you don't have to worry about clearing your cache all the time. Okay, so the beauty of this then is that all of that stuff is just done for you. You don't have to worry about setting up all of the individual pieces. So then you can come into your application right here, and all you have to do is type npm run hot. So Webpack comes with its own server. It's a hot reload server, meaning as I change the code, it automatically reflects those changes in the browser without me refreshing the page. I'll show you that in just a second. We have a number of scripts set up with npm that allow you to npm run tests. So we have Karma set up to do testing. We have a build process. So if I run npm release, I'll show you here in a sec, it'll deploy the app. Okay, so when I do that, you can see that we're using Gulp as well to actually handle the build. It does just a couple little things like copy images and other assets into the correct directory. We allow you to do this index. If you put TPL in the file name, then Gulp will recognize that and it will switch out the code in the HTML. In particular, these includes. So this is a really, really basic include system. If I have a header file that's common amongst all my files that I'm going to add to this project, I can throw stuff into a header file and then include it. Do the same with Google Analytics. And then, of course, here's my app Webpack bundle files. How all the JavaScript ends up in the project. So here's the actual React code. We'll start with this one component because it's super simple, but it's a little bit deceptive in that it is simple, but there's a lot going on here. First off is the thing we talked about. You see there's some ES6 syntax where I import a library. The library I'm going to import is just React. So that's the only thing I need to do what, the simple bits of code that I've got in this file right now. The other part that you'll notice is this. So up until last year, maybe the year before, whenever I started writing code in React, I would have told you this is the worst idea in the world. For the past 15 years, the general, the development community has insisted that you separate styling from logic, right? So we have MVC patterns. That's common, like if you write Ruby on Rails code, or really if you've worked in any language, ASP.NET, I'm trying to think of some others that do this, but they would separate the display, the HTML, from the actual processing of data, the handling of the logic. And then React comes along and they say, no, we want to keep all of the display alongside all of the logic. And when I saw this the first time, we were doing a lot of Ember development, and I dismissed this as ridiculous. And most people do the first time they see that kind of code, because it does look kind of ridiculous, right? And if you notice, there's no quotation marks around this, right? We don't do that. So it's not a string. Before this is executed in any browser, or before it's run in any test, this is transpiled. So this is what's called JSX. So React came from Facebook, and the engineers there decided that, number one, we want to make React components fairly easy to write. So they came up with this JSX model. So the transpiler is going to take that, recognize it in the code, and turn it into a function before we execute the code. And the reason that we do that is something called the virtual DOM. So you might have heard that term used. If you've ever heard React or done any, well, if you do JavaScript development, virtual DOM is one of the buzzwords at the moment. The idea is that I keep an object in memory filled with all these functions that reflects the DOM that is displayed to the end user. And when I do that, I can quickly check that virtual DOM for changes and render them out to the DOM very, very quickly. So let's play around with this and see what I mean. I've got the React starter app running here somewhere. Just one second. Port 8021. Okay, so there's our super basic React application. It doesn't do anything other than say home. We could do this though, and run release. And this will deploy it up to Amazon fairly quickly, and we can go look at it live on the server. Does anybody have any questions so far? No questions? Yeah, exactly. So if you want to start using this application, or if you just want to use the starter kit rather, just come out here, grab that URL. If you've got Git installed, let's see, make that bigger. Just clone it. One of the first things you'll want to do is oh, sorry. Actually, when you clone it, sorry, I should have done this the first time. Clone it into whatever your project name is going to be. So, like, this is my new project, whatever. All right. So when you clone this, it's going to be pointing to the original repository. You're going to want to go out and create your own repository. So you're going to change that Git remote origin to whatever repository you want to deploy to. And if you want to continue to pull in updates, so if we make updates to the starter kit, and you're like, oh, I want that, you can just change this to something like upstream. Just do this. Don't change the master one to upstream. Keep that one as origin. Or you can go run the git commands to do this. I would just edit the git config file because it's easier. So once you've done that, then you can just follow these instructions in the README. It's fairly simple. One of the things you'll do, we've got this .env, change that from the example to .env, and that will make it specific to your machine. Because we have multiple developers working on a project at any given time, and we use another piece of software called ngrok. Ngrok makes your application publicly available on the internet, so it creates a tunnel to your computer, so you get a URL. We do that for various reasons, but because we do that, two developers can't share the same URL. So you'll come into here and you can configure ngrok to do that. So you'd say, I want a different asset port, and I want the URL to be, my new app right here. Oops, don't use underscores in URLs. And then by doing that, this becomes available on ngrok. Anyway, so that part should be fairly fast. Let's check something else here. If I go grab, oops, that. Okay, so that actually released it out to Amazon. I'll show you that for a second. I'm going to try one more time to get this to work the way that I expect it to work. Oh, okay. Okay, I'm going to just leave that so that we can take a look at another app that will show you how to use more of these technologies. So, whenever I change these React is built with this notion of components. And it's fairly simple to come in here and take a design from, well, the HTML and CSS from one of your designers and just paste it into here. And then you can see an entire page get rendered. And then you can take that apart small pieces at a time and add the functionality that you need for particular pieces of a given application. So I might have a list of users or a list of items that I need to display. And the designer will give me some dummy design that shows those designers. I can then extract those out into individual components, and then this becomes something more like import my component from /components, wherever you want to put this. All right, and then inside of this code right here, instead of just returning an H2, I can return a div, and maybe I'll keep the home page part right there. And then I treat this component that I've written just as if it was another HTML component, that I've had full control over. And that would render that individual component into that position. Okay, so having said that, we're going to take a look at another piece of technology, because this is helpful when you want to create an application that doesn't require a server backend. And I've actually seen a number of instances where that's really useful. But, well, in particular when you're calling other people's APIs. So in the past, you weren't able to make CrossOrigin requests. Is everybody familiar with that? So current, if the browser attempts to make a request to a domain that isn't the current domain, it'll come back and it'll tell you that you can't. Then we invented something called JSONP, which was a hack to make that work. So I can make GET requests to servers that I did not originate from. So if I come from example.com and I want to make a request to api.google.com, I could do that if I used a JSONP request, because that would get around the security limitation in the browser of making a request to a domain that I did not originate from. That's kind of an ugly hack and kind of painful. So in the latest iteration of browsers, we've enabled something called CORS. Has anybody heard of CORS? So it's CORS. It stands for Cross-Origin Resource Scripting. Basically, you go into your server and you configure it so it sends down values in the headers that say it's okay to make a request to me, and I will allow these specific origin domains. And a lot of times, if you have a public API you will allow anybody to make a request to you. If you have a more secured API, then you might have to deal with partners and say, we'll only allow requests that came from example.com or whatever. But by doing that, then, we've opened up this whole new possibility of writing front-end applications that have significant functionality because they can talk to APIs on the back end. All right. Now the question becomes, what if I do need a back end? What if I need data, right? I've worked with a company called Firebase. Anybody heard of Firebase? Any Firebase users? Anybody sign up and play with Firebase a little bit? A couple of times. All right. So Firebase was acquired by Google earlier this year, so they'll be around for a while, hopefully. They have a great team. They actually invited me to come out and hang out with them at Google a little while ago, and I want to show you how. Again, you do not have to have any server infrastructure, but you can build some interesting applications. Okay. So hopefully this one works a little bit better. I have this React Firebase starter app. It is simply a fork of the React starter app. It is basically the same exact code, and I'll walk you through a couple of differences so that you can see React in a slightly more interesting and sophisticated scenario, and hopefully this one works a little bit better given that the other one seems to have problems with the internet here on campus. All right, here's that same home.jsx. It's the exact same file. So here we had this home.jsx. There's only one file in this application. Here again we have home.jsx in the Firebase application. Now there's a couple of differences here. One is I have Firebase. So it's worth understanding how you get a hold of some of these tools. Let's make that bigger. All right, so here's the Firebase starter app. I'm going to go into the client directory. That's where all of my JavaScript lives. You run npm install --save. If you don't do the save, it won't be added to your package JSON. So there's a package JSON in your JavaScript files that says, here's all the libraries that you need to run this application successfully. So Firebase. So npm install save Firebase. And I already have it installed, so no, it's going to go out and install it, and it takes just a second. Okay. So to add Firebase to your app, that's all you have to do. So that's step one. That allows me to import Firebase from Firebase. I have these stores set up. I'm not going to go too much into the Flux architecture, a lot of React applications. If you are interested in Flux, come and talk to me, and I can walk you through some of the details. And I'll show you this diagram. So this is what, where is it? This is what Flux looks like. It is a one-directional data flow. So your components, which are these React views, have things happen to them, like people push buttons or people type in data, something like that happens. It calls out to these action creators, which are just functions. Go ahead.
What's the difference, like the big difference between Flux and Redux?
Oh, that's a great question. And probably a bigger, so the big difference is Redux does away with bits and pieces of this. So I would say this architecture is worth becoming familiar with so that you understand kind of the mindset of the developers who are creating React. Redux is sort of the new hotness in the React community right now. Stores and actions kind of get merged together in Redux. You don't have multiple stores in the Redux architecture like you do in the Flux architecture. So in this architecture right here, that store might be my user data, or it might be a list of students in a classroom. It might be whatever your data domain is. That's what's going to live inside of the store. In Redux, you have one store. It's just one massive data set. It's usually an immutable data set. So a lot of people use immutable.js with Redux. That way, anytime you make a change, the data that is changed results in a new store, more or less. Not really, not actually in memory. Immutable.js has a really great way of handling changes that doesn't copy everything, but it makes it pretty fast to determine whether or not changes have made. So going back to that whole virtual DOM idea, in each node in the virtual DOM, you have to say, did I change? Do I need to update the actual DOM in the web browser? That's not terribly expensive. It works pretty fast. But if you have an immutable data set where I can do comparisons against references to say, is this the same reference as it was before? Then it's super fast, right? Because I don't have to actually calculate what is the result of that render function. I can just look at the data and say, did my data change? And when I say look at the data and see if my data changed, I mean look at the references to that data. And if they're the same, I can go on my merry way and leave it alone. That makes sense? So, yeah, if you've got time, take a look at Redux. It was more or less announced, I guess, at the React conference in Europe in August. There's a couple of videos out on YouTube. YouTube is actually a really great resource for finding all kinds of information about all the latest and greatest technologies. If you're really interested in React, go out and watch a bunch of the videos from React Conf Europe. There was also React Rally here in Salt Lake back in August, right? Yeah, I think it was in August. The videos from that are up online as well. So you can learn all of the more detailed pieces of React that way, which are many. Go ahead.
Yes, not knowing a lot of this stuff, like what's, is there like a specific name for the structure of this kind of system compared to like MVC?
Yeah, so that's a great question. He asked if there's a name for this compared to something like MVC. So MVC model view controller architectures are common, in Django and Rails. We've seen those. MVC's been around since the 70s. It's called Flux. Facebook made it up and they called it Flux. So that's kind of where this came from. And then, the guy who created the Redux architecture called it Redux. It's not that I don't actually know of any literature in computer science to back up these newer architectures. So they're still kind of experimental in some ways, but we've been using them with a fair amount of success in actual production applications.
So the different pieces of software that you're putting together are just different parts of the system?
Yes. So the pieces that you see on the screen here that represent the Flux architecture are a piece of, let me go back to the React starter app here. If you look in the client directory, in this JS, sorry, you can't see there's a JS directory inside of here. It has a folder called Actions. It has a folder called Components. It has a folder called Stores. So those match this. Let me pull this over here. Those folders match, Actions, Stores, and the components or the views right here. So each one of those is going to contain, the JavaScript to handle that. The rest of everything that I've kind of told you about is tooling. It's your JavaScript tooling, which is boring to figure out and set up. So that's why I say go out and just clone this repository, because getting your Git config just right so that the hot reload server works and so that you can deploy it to Amazon, all of that, it's not fun, right? Like, that's a pretty boring thing to have to deal with. So we're saving you all of that. So anytime you have like a hack fest where you've got a limited amount of time to go out and build an application, just go grab one of these, and then you're already miles ahead in terms of getting set up, so that you don't have to deal with all of the, like I said, like all the boring stuff. Okay, any more questions? All right, so that, like I said, I'll mention Flux. Go out and you can just do a search for Flux. You can go look at Facebook's GitHub repository. You can look at the diagram, kind of get an idea for this one-directional data flow, but then, as you mentioned, I would personally go spend your time learning Redux if you're going to go look at an architecture to back up your React components. So React components don't have an architecture. They're just the view part of your application. So if you need to be able to handle sophisticated data or sophisticated user interactions, and you want to architect that in a way that's easy for others to read and look at, you'll need something like Redux or Flux behind it. Or hopefully here soon, we'll have Relay, which actually you can get Relay right now. It's in kind of a alpha beta state, but it allows you to declare the data that your components require to render, and then the relay code will assemble all of those requests from all of your components into a single request. It will remove the duplicates and then sends that up to a GraphQL server where it decomposes that request, gets all the data from the different data stores, and then sends that down as a single unit, and your components just magically update. It's actually really, really cool. There's a couple of presentations on GraphQL out on YouTube that I would encourage you to go check out, but both on GraphQL and on Relay. I think Relay is the part is the library for the client applications, and GraphQL is sort of the language used. I think they have a Node.js server on the back end. There's work in progress, a number of open source projects in Ruby and Elixir and Python and all the languages you can think of to implement GraphQL servers on the back end. So hopefully, with the right community support, we'll see a lot of that show up over probably the next year. All right. The other option is to use Firebase. And if you don't want to have to set up a whole bunch of backend stuff, this is a pretty good way to go. Firebase makes it super simple. In some ways, it kind of looks a little bit like the backend Relay servers to me. It doesn't allow you to do the declarative data, but it does make it super simple to add sophisticated functionality to your application in terms of storing data and handling that data in real time. I was going to type this out, but I'll just go really fast. So this first part right here sets up just gets the URL. So Firebase is a document store, meaning you have a root node, and then you can have items that hang off of that node. So in this case, I actually call it items. You could call it users, or you could call it sandwiches, or you could call it schools, whatever you want to call it. You can basically begin to partition your data down into these different scopes based on that URL. So when you access data or when you write data, you write to a given URL. That's all that this is. And if you look in the settings store, again, that's the whole Flux architecture thing. That comes from here in our applications in the React apps that we've built. So we just have this window default settings, and you can see that I have this Firebase URL. This looks kind of like server code that you may have run in the past. It's not. It's just a string replace that Gulp does. It pulls that URL from the environment file. So here's my actual Firebase URL. They kind of look a little bit ugly, but I think you can go in and configure those if you want, but most of the time you're not going to care. So that URL/items is where we're going to go and write some items. This creates the Firebase reference. So I'm going to need a reference to be able to talk to Firebase. So you just create a new Firebase object, you give it the URL. This is the initial state of my React components. So React components have properties that are given to them by somebody else. And then they have state, which is a state that's actually internal to the given component. So the properties, if you remember in this kind of lousy example I started writing back here, I have this my component. I can do things like user equals whatever store dot go get a user. And when I do that, inside of the my component, I'll have a property and I can access it this.props.user. I can't change those, I can only receive that data from my parent. State, on the other hand, is information that I can hold internal to my component, and I can change it and modify it and do anything I want. And anytime my state changes, and this is the key part of React, when my state changes, the component will re-render. So you as a developer get to think of it as this render method is called. Whether or not that actually happens, you don't have to worry about. It's like getting to refresh the page over and over again. So if you've ever written complex applications, back in the day before we did lots of JavaScript, the way that you got a new page was you went to the server and you asked for it. And the server would do all kinds of stuff and assemble a page and it would send it down to the client. Well, that's great, especially as a developer, because it's a stateless system, right? Like it's a one and done. I've assembled this HTML, I've put this data in, and now I give it to you and we're done talking to each other. And then the user clicks a link and it goes back to the server again and it sends all this data down. The problem with that is that it doesn't let you develop very rich applications. So you end up with a situation where the user has to wait. Users don't like to wait. So we went to this really rich front-end client ecosystem, right? We have Ember, we have Angular, we have React, we have Backbone, we have a myriad, Knockout.js, tons and tons of different JavaScript frameworks to make this simpler. And the hardest part of writing a JavaScript application was getting it into the right state. So you've probably done this. You find something really cool on a website. You're like, wow, this would make a great Christmas gift for my dad. I'm going to send this to my mom and say, go buy this, right? So you copy that URL and you send it to her, and the page that she gets is the homepage of the website, or an error page, right? Like this has happened to you. It happens to me. That's because the guys who wrote those applications didn't care about the URL reflecting the state of the application. Their JavaScript was not sophisticated enough to know that the user cares enough to send that URL to somebody else, and it should restore the entire state of the app. So React solves that by allowing you to mentally think about refreshing the page every time you do anything. That's really nice. So I can think of this render method being called anytime any data changes in this application. It's like being able to round trip this to the server, like what we used to do. I don't have to worry about the application becoming stale. I can use those properties in this state to get information from the URL using React Router, which is another library that's already in here. I can take that URL, I can decompose it into its individual parts, pull out IDs, pull out paths, figure out where I'm at, and I can give the user that exact same experience as the person who sent them the URL. And that's really cool, and it's really powerful, and it's how the web should work. All right, so getting back into here, you can see I've set up state. This is a default state. It's an empty string and an empty object. I don't have any items yet. I don't have any text. And so I'm done, right? Like, it's an initial state, and you'll frequently run into this, right? Like every time you write any code, you need to, like, I'm going to make this name variable some initial thing, right? Or maybe it's, oops, can't even spell my name like that. That's all that you're doing right here in the constructor. This is actually really interesting because up until ES6, we didn't have constructors in JavaScript, and all of a sudden we have constructors, and we have classes, right? So a class is an actual thing in ES6. You can see that I'm extending a React component. You can write your own classes and then extend your own classes. So that can be really powerful for sharing code throughout your application. This component will mount as part of the React lifecycle. It means the component is about to be put onto the page. It hasn't yet, but it's about to be. So in that method that is going to be called by the React framework, we can do some interesting things like set up all of these Firebase references. So here's all you have to do. On the Firebase reference, anytime a child is added, we're going to execute this function. Anytime a child is removed, we're going to execute this function. We're given a data snapshot, which is kind of a wrapper around the actual data. The data lives in data snapshot.val, but I'm also given a key. Remember that the Firebase store is this hierarchy. It's a document store. So I have a root node, but then off of that node I have some key and then my data, and then some other key in my data. And that key might be the items that I showed you on that first screen, or it might be a randomly generated value. And in this case, we're going to add some items, and you will see the randomly added keys, and this allows us to get a hold of those keys. And the reason that's important is because when we want to remove them, we have to be able to delete them from the object that we have. And then component will unmount just means that the component is being removed from the page, whether the user is exiting the browser or they've navigated to a different portion of your application. We're pulling that component out of the DOM, and so we need to make sure to get rid of the Firebase reference, otherwise we're going to have a memory leak. So that allows us to kind of clean up. Okay, so this application looks like this. Let's see if we can make this bigger. Oops, too big. It's really ugly. I don't put any styling in these because inevitably when you write your own apps, you end up ripping the styling out, and then that wastes your time because you don't want to have to deal with, maybe you don't like Twitter Bootstrap, or maybe you don't like material design or whatever styling. So sorry It looks ugly, but it's hopefully it's functional. We're about to find out. Like I said, I have some internet issues up here. But I should be able to type 5. There we go. Okay. So you can see we built a to-do list on that home component simply by adding this handle add. And then when I hit delete, we have this handle delete. So how does that work? So I have my render method here. You can see once again, here's those little bits of HTML looking code. It's just a div that renders out an input. So here's my input, right? That's the input part. Type as text. You put a ref on it because that's how you're going to get the value with React. On this button click, this looks like old school JavaScript, right? Like on click. We stopped doing that when we started using jQuery, and now we're back to it. So on click, we're going to call this function. So here's an arrow function. Again, it's a little bit of ES6. On click passes an event to me, which I may or may not care about. The beauty of this arrow function is it will bind this to the class. So if you've ever worked in JavaScript very much, you'll know that this is not always the thing that you think it is, right? Like it changes based on your context. So usually in an event handler, like onClick is an event handler, the this would actually be the calling context rather than the this that is my class. The arrow function makes sure that this is the class. It's this thing up here that I wrote, this home class. It handles all the binding for you, which is really kind of cool. So I pass in my event, and then I can keep you from doing the default, which might be something like submitting a form. Browsers will still do that. So when you're writing your JavaScript, you have to make sure that pushing a submit button doesn't actually submit to the server and wipe out everything that you've done. This right here is just a map. We use Lodash, so the underscore is Lodash, lets me do functional things like map, grab all the items out of the state, and then generate that list of items, which also have an onClick that handles the delete. Okay, so with the delete, I pass it an ID, then I can make a new reference to a Firebase URL with that ID, and just calling remove gets rid of it. So right here we have Firebase ref push. When I push on add, that adds a new item to my database, remove removes it. Simple enough. So if you go, let's do this. So this has all the directions on how to use Firebase down here. If you want to deploy to Firebase, they have a quick start, but basically it's just install the Firebase tools globally, build the application, and then run deploy. So if I do a Firebase deploy, then that'll be up on the web. So again, you don't have to worry about configuring servers. You don't have to worry about setting all that up. It's kind of just done for you. And I can do Firebase open. And here's the live application. And if you go to that URL right now, somebody go to that URL. Joseph, go to that URL. Or can you see that URL? Sorry. Let me make that bigger. You don't have to type in that far. So is anybody there? Okay. So type in the, there you go. So everybody type in the box at the same time. This is the other cool thing about Firebase, is the updates are in real time. So anything that I do, yeah, thank you. I'm assuming that's Ben. There we go. So not only do you get back-end database functionality, but you get real-time back-end database functionality. This can be really powerful if you're writing a chat application. Or nice. I knew this would happen because I was like, oh, these are colors. But if you're writing a game and you need real-time data to be transferred between the players, you can do this. And you get all that with just a few lines of code. And that's what's really cool, is this entire file, including the ability to render, is only 59 lines of code. So setting up Firebase is really simple. Getting back-end services is simple. And again, super cheap to host. Firebase has a developer plan. It's free. So you just go out and get that for free. You can go out and the Google APIs are free, so you can write sophisticated Google API or Google client, right? Sophisticated applications that are client-side only that use Google APIs, or any number of other companies. Go out and look around, and you'll find all kinds of interesting opportunities. Yeah.
So with Firebase, all your data is still on their stuff, but you still don't need your own server to run it.
Correct. All their data lives on their servers, so you don't have to do anything. There are a couple of other companies. Facebook, I think, has one that I don't remember the name of right now. There are a number of companies because this practice of writing client-only applications that use somebody else's architecture on the back end has actually become quite popular. There's other ways you can do this. Is anybody familiar with Lambda from Amazon? Not Lambda, the keyword in Python, but Lambda, the service from Amazon. Anybody use it? Joseph's used it. Lambda lets you write functions, a single JavaScript or Python or Java function. It can interact with all of the different Amazon services. So maybe you have a database on Amazon, or maybe you just want to write a file to S3, or maybe you want to proxy a request from a client application to an API that doesn't have cores enabled. You can use Lambda for all that. Well, Lambda plus their API gateway. Lambda, I think they give you 1 million requests per month for free. So again, you can build very powerful, very sophisticated applications without hosting anything on your own and really without paying for anything. So that's kind of it.